Hey everybody, let's go over this problem 516 which deals with bond valuations and really takes a look at interest rate sensitivity. Alright, I'll read the problem. A bond trader purchased each of the following bonds at a yield to maturity of 8%. Immediately after she purchased the bonds, interest rates fell to 7%. What's the percentage change in the price of each bond after the decline in interest rates? Fill in the following table. And I'm going to solve the first row, the second row, and the last row. And the rest I'm not going to illustrate because it's essentially the second row with just changing the term of 10-year to a couple other terms. And I've worked that ahead of time for you. Okay, so really this is the price at 8%, this is the price at 7%, and this is the percentage change. Okay, so if you go here, you can look up top and you can see there's the formula. So the 8%, the present value of a 10-year 10% annual bond is $1,134.20. If I hit the formula bar, we'll get this pop-up screen and you can see where I came up with the numbers. The rate is 8%, number of periods is 10. The payment amount would be equal to the 10% coupon value, that's the stated rate on the bond, times $1,000. In all cases, if no face value is given for a bond, you assume it's $1,000, which is the normal face value of most bonds. I enter it as a negative because I want the answer to come back as a positive. So we're going to assume that the present value is a positive number, and we're going to get that in exchange for these outflows. But in actuality, it would be just the opposite. You would buy the bond, giving up money now, and in return, if you're the investor, you would get these back. But I'm doing it the opposite sign approach so that we get the answer with a positive number. And the future value of the bond is $1,000. So once I enter that, I come up with 1134. Okay, then all you have to do is copy that same formula to here, and we get the same formula, only now it's 7%, right? So if I call this up, we get a change of 7%. Everything else is the same. Therefore, the bond drops from 1134 and change to 1210 and change, and then the rate of change is simply the difference divided by the base. So B19 minus C19 divided by B19. Okay, and then a 10-year zero coupon bond doesn't have any payments. So what we do here is we say the rate is 8%, number of periods is 10. We leave payments off and we get $1,000. So it's sold at a deep discount. So the fair value is $463. When we copy that to the 7%, formula looks exactly the same except that this one is 7%. We get 505, and then we compute the change as well. And then finally, for a perpetuity, remember that a perpetuity, you simply take the payment divided by the interest rate. So all I've done here is taken $100 and divided by what's in cell, what's it say, B11. Boy, I'm not sure I did that correctly. I think when I copy this, it might be different. Let me redo that. It's $100 divided by B18. Yeah, and that's $12.50, and then I can copy that here, and I get 100 divided by C18, so we get a net change of $14.29. And let me state that correctly. That's a net change of 14.29%. So we've got a and I ought to state the percentages right. This one's a drop. This one's an increase. B20. You know what? Let me redo these because this doesn't look right at all. B19 minus C19 divided by B19. That's correct. And this should be a B20 is higher, so I'm going to just change the sign because that's a positive change in value. And this one increases as well. So let's make sure that's correct. And I think we've worked this one. Yep, those are the correct values now. Sorry for having the wrong sign in there. Now I've got it fixed. And that illustrates interest rate sensitivity.